Hello, you all. Welcome back. So the topic before us now is reduction and oxidation reaction. Okay, this is abbreviated as redox reaction. Okay, so now we're going to start with oxidation reaction. We're going to start by defining oxidation reaction. What is oxidation reaction? Okay, now there are different definitions for oxidation and reduction reaction, but I'm going to limit my definition based on electron transfer. Okay, on basically everything just centers around electron transfer. Okay, so now based on electron transfer, I can define oxidation, okay, as a reaction that involves the loss of electron. Okay, while reduction reaction is a reaction that involves the gain of electron. So which simply means that a substance is said to be reduced when it gains electron. Okay, and a substance is said to be oxidized when it actually loses electron. Okay, so now let's now talk about oxidizing agent and reducing agent. Okay, now an oxidizing agent is a substance that actually gains electron and got reduced, while the reducing agent is a substance that loses electron and got oxidized. Sometimes students do confuse the agent from the actual reaction. I think I will have to explain that using an example. Okay, a typical example, let me clear my screen. Okay, typical example is a reaction in which let's say sodium, okay, was oxidized, and sodium is oxidized, will definitely be oxidized when it actually loses one electron. If it loses one electron, okay, it forms sodium ion, sodium plus. This is oxidation reaction. Okay, now every oxidation reaction is being accompanied by reduction reaction. They don't work independently. That's why it's called redox. Okay, because if a substance releases electron, definitely another substance will gain it. Now let's now see, okay, a reduction reaction in which chlorine, okay, gains this electron that was, and of course because Cl minus. Okay, so this one here is oxidation. Excuse me. Okay, so the very first reaction here is oxidation reaction, while this second uh is reduction reaction. Okay, so now how does that explain reducing and oxidizing agent? Okay, now a reducing agent, okay, let me start with the reducing agent. Okay, is an agent that actually causes reduction. Just simple. A reducing agent is an agent that causes reduction. So if I should ask you which agent actually causes the reduction of chlorine, definitely sodium. Okay, so because it was sodium that actually gave out the electron that, okay, chlorine actually took. So it was one that gave out the electron, or uh, releases the electron for chlorine to be, okay, that actually made chlorine to be reduced. Okay, so invariably the substance that was oxidized now becomes the reducing agent. Okay, now for what one is the oxidizing agent? Yes, chlorine here is the oxidizing agent. The substance that is actually being reduced becomes the oxidizing agent. Why? Why? Because it is this chlorine that actually that accepted the electron, or took the electron from sodium, that made sodium to be what? Oxidized. So please take note of the difference as we proceed. Okay, now, okay, so that's a subtopic here. So look at oxidation number. Okay, now oxidation number is the charge a substance is said to have as determined by some set of arbitrary rules. Okay, now of course, for you to actually know which substance is actually oxidized and the one that is reduced, okay, it's simply going to be, let's say, an equation of this nature. Okay, how do I know what happened here? Okay, oxidation and reduction, and it's called that for me to see sodium having plus here, all right, that shows that it's being oxidized. See chlorine having minus here. Okay, so oxidation number is actually the charge a particular substance is said to have as determined by the set of some rules, arbitrary rules, which of course it is going to be rules. We're going to be looking at the rules that determine the oxidation number of actually a substance. The rules that determine the oxidation number of a substance. That's what we are going to be looking at. Okay, let's look at this rule. The rules used to determine oxidation number. Now, number one rule is this: oxidation number of a free atom in an uncombined state is 0. So, as simple as what you've said there. So we simply mean that oxidation number of sodium here, without being combined freely, okay, is 0. Oxidation number of chlorine, okay. So any atom that is actually free in an uncombined form, all right, its oxidation number is 0. Okay, oxidation number is 0. That's number one. Number two, algebraic sum of the oxidation number of atoms in a compound is 0. So when you sum the oxidation number of all the atoms in a compound, it should always give you 0. Okay, for example, if I should sum the oxidation number of course you know very well that this reaction, okay, that happened here, this redox reaction is a reaction that actually leads to the formation of sodium chloride. Okay, you know very well. So now second law said that if I just should sum the oxidation number of the element in the compound, it should give me 0. So let's look at that. The oxidation number of the valency of sodium is +1, you know so. Then the one of chlorine is -1. +1 minus 1 is 0. Okay. So oxidation number, the algebraic sum of the oxidation number of atoms in a compound, all right, should be equal to 0. So that is this. Then oxidation number of an ion is equal to the charge of the ion. So if I have an ion, let's say Mg2 plus, the oxidation number of Mg2 plus is just +2. Let's say if I have a radical, okay, of let's say SO42 minus, the oxidation number is -2, right? So please take note of that. I think there are some questions we could actually solve. Here we go. So the question goes as, okay, what is the oxidation number of Z in K3 ZCl6? So let's say Z is an atom, but that I don't know, it's an unknown atom. Okay, so how do I get the oxidation number of Z? Okay, of course, this is actually a compound. Okay, so applying the rule, number 2 rule, oxidation number of a compound, right? That's K3 ZCl6. Okay, so the algebraic sum of oxidation number of all the atoms in the compound should be equal to 0. So for chlorine and for potassium, don't forget that the valency is +1, right? And I have 3 atoms of potassium. I multiply by 3 plus the oxidation number of this that I don't know, I'm looking for, right? Z. Then plus chlorine, the valency of chlorine, of course, you know that is -1. Multiply by 6 equal to 0. This is gonna be 3 plus Z -6, right? Equal to 0. Of course, 3 minus 6 is -3. Then now Z will not be -3 goes over, that's going to be +3. Okay, so +3 is my answer to that question. Now the next thing we're going to be looking at is how to determine the reducing agent and oxidizing agent in a reaction. Okay, if a redox reaction occurs, how do we actually know the reducing agent and oxidizing agent? Okay, now to determine the reducing agent and oxidizing agent in a redox reaction, we evaluate the change in oxidation number. An atom that has an increase in oxidation number is the reducing agent. Why? Because it is being oxidized, okay, and vice versa. Okay, so increase in oxidation number means oxidation, and reduction in oxidation number means a reduction. Okay, that's just what that is simplifying. Let's look at a typical example. Let's see a reaction here where you have copper 2 sulfide reacting with oxygen to yield copper metal plus sulfur 4 oxide. So the question is, what is the change in oxidation number of copper in the reaction? Okay, so we are going to look at the change of oxidation number of copper from the reactant side to the product side. Let's start from the reactant side. Okay, copper in the reactant side is found in copper 2 sulfide. So, and of course that's a compound, copper 2 sulfide, which we know that the total oxidation number is equal to 0, right? So I want to find the oxidation number of copper in this compound. That's going to be, of course, 2 atoms of copper, right? That's 2Cu. And you know very well that oxidation number of sulfur is -2, right? All right, equal to 0. So take this to the rest of the equation. So now have the Cu to be equal to 2 all over 2, okay, which is +1 at the reactant side. Okay, so copper is +1. Then at the product side, copper is just a free metal, that is 0, right? So at the product side, copper is 0. So oxidation number of copper actually changes from +1 to 0. So what does C? +1 to 0. Now the question is copper oxidized or reduced? Copper actually decreased from +1 to 0. So copper is what reduced. And of course, if copper is reduced, it is the oxidizing agent. All right, so I hope that is well understood. As we proceed. Okay. I think I'll still get that question again. Now, if Y is an oxidizing agent that reacts with a reducing agent Z, which of the following is correct? So Y is oxidizing agent, right? So let's look at which of this is correct. Y increases its oxidation number. No. An oxidizing agent is always reduced. Okay. Y become reduced. Yes, B is the correct answer. So as simple as that. Let's solve this. The oxidation state of chlorine in HClO4 is, okay, it's simple, very simple. HClO4 is a compound, right? So +1, they are looking for the one of chlorine, right? Remember, plus chlorine, I don't know. Then of course you know very well that oxygen, right, is a -2. Valence is -2. Then times 4 atoms of oxygen is equal to 0. Okay, so this is 8, right? So I'm gonna have 1 minus 8. This is -1 minus 8, which is -7. So I'm having Cl -7 equal to 0. So Cl now, that's gonna be +7. Okay, so +7, C is the correct answer. The oxidation state of chlorine in HOCl, HCl3. Let's write them down. HOCl, HClO3, and HClO4. I think I've done HClO4, right? Because that's what we just did. So this is already +7. Let's do this one. This one is +1, right? Plus Cl, of course, 3 times 2 minus 6 is equal to 0. It's equal to 0, right? So if you actually have +1 minus 6, that's -5. So the Cl here is going to be equal to +5. Then this one here, the same +1, right? I think I did that. Okay, no. So this is going to be plus 1, right? Of course, minus 2 plus Cl is equal to 0. Okay, so this minus 1, then Cl now is going to be equal to plus 1. Plus 1 plus 5 plus 7, that is our answer. Plus 1 plus 5 plus 1 plus 5 plus 7. Okay. Okay, so here another question. A reaction, okay? For this reaction, we are being asked the oxidation number of manganese, okay, in the above reaction changes from. So let's see what manganese is at the reactant and what it is at the product. First of all, let's start with the reactant. At the reactant, manganese actually exists as a radical, okay, radical ion. Let's get its oxidation number. So at the reactant, manganese, that's MnO4 minus, okay. So of course, this is an ion, MnO4. Remember, the oxidation number of an ion of, okay, or even a radical is equal to the charge of the ion, right? So in this case now, I'm looking for the oxidation number of manganese, that's Mn. Then of course this is 4 times minus 2, that is going to be minus 8. Okay, oxygen, velocity of oxygen is minus 2, so it's equal to minus 1. So I'm having Mn now is going to be equal to minus 1, okay, plus 8, which is plus 7. But at the product side, manganese here is just Mn2 plus, okay. At the product side, we have manganese being 2 plus. So that means the oxidation number of manganese at the product side is this plus 7. Pardon me. Okay, plus 7. So here is plus 2. So oxidation number actually changes from plus 7 to plus 2. So manganese was reduced, okay? Plus 7 to plus 2A. All right, so I think that is actually the end. We're going to look at more example and more question. All right, see you in the next video. Thank you very much.